Hi everybody, this is a beautiful question that deals with congruency, or I should say congruent triangles. I have prepared a detailed notes on congruent triangles and I've also attached the link in the video description. So kindly, if you want to shed some light or have some detailed understanding on congruency of triangles, you can please watch that link and better your understanding if in case you really want to. So having mentioned that, let me draw the figure for this question. So you have a triangle like this and we are expected to find the area. So okay, so that's the triangle. This is A, B, C. We have this side to be given as 25 and this angle is 2x. This angle is x and this distance is 40. So we are expected to get the area. Now foremost, what we have to do is we would have to create a triangle within this triangle. Now when you are creating a triangle, make sure that the line that you're drawing is exactly 25 units. Of course, we are not using any scale or measurement. So the best way to represent is that draw a triangle in such a manner that you are creating an isosceles triangle. So how do we know the triangle created is an isosceles triangle? Simple. If two angles are equal, then outrightly we can conclude that the triangle created is an isosceles triangle. So this is isosceles, right? So this is the requirement for an isosceles triangle. So what I wish to do is I would like to create the isosceles triangle. This is going to be 2x. So let me give you the statement of the theorem in this case. So the statement is as follows. If two angles are equal, then the sides which subtend the equal angles will also be equal. Now this is approaching this question from the angle perspective. Now we can also approach the question from the sides perspective, so that is also possible. So having mentioned that, clearly this is 25, it's given. These two angles are said to be formed to be equal. In fact, this is 2x, it's given, and we created this. And based on this property of the criterion that judges for isosceles, I can outrightly state that this is also 25. Fair enough. Now this is an exterior angle. So let me just consider A, B, C, D. Let this point be D. Now angle D is an exterior angle. Exterior angle for triangle ADC, right? For this triangle ADC, angle D on the other side, it has an exterior point also, right? Angle D is equal to 2x, right? Now what is the law of exterior angle states? By the law of exterior angles, what does the statement says? 2x, or I should say, okay, let me state 2x. So 2x would be equal to sum of the interior angles, or I should say opposite 2x is equal to sum of the opposite interior angles. This is important, opposite. So you can't take this angle, but you can take the opposite interior angles. Now I know this is angle C, which is already given to be x, but I need to get to x. So what would this angle be? So this angle is going to be equal to x. So if I were to take this picture into account, clearly two angles are equal. Now if two angles are equal, then the sides which subtend the angle will also be equal, right? This is the important part. So using this theorem, I can clearly say this side AD subtends is responsible for creating the equal angle on this end, and DC is responsible for creating the angle on this end, right? So this would mean 25 will also result in this part also. So you got 25 here, and this will also be 25. That's the understanding. So you can probably mark it if you want, but it's clearly visible. Now why did we have to do all of these things? Because to get this 25. So have that in mind. Now next, what I wish to do is I would like to draw a perpendicular, right? I would like to draw a perpendicular from this point down, right? So that drops. So this is going to make 90 degrees. If this makes 90 degrees, this will also be 90 degrees on this side, right? So this is 90 degree, this is 90 degree, this is 2x, this is 2x. So clearly you can see two angles are equal. Now we know that the sum of angles, let me state this statement, sum of angles in a triangle is equal to sum of angles in a triangle is equal to 180 degrees, right? So that will mean if this is 2x and this is 90 degrees and this is alpha, this is equal to be 180 degree for this triangle. So let me consider triangle A, B, say E, okay, A, B, E, A, B, E. Also, if I were to consider triangle AED, what is that AED? I got a 90 degrees and then I got a 2x. Then if I were to take this say some beta, this would be equal to 180 degree. Now clearly you see I got a 90, I got a 90, I got a 2x and a 2x. So this would mean alpha is equal to beta. So that is what is going to help us. So this and this are equal. Both the angles are equal. Now let me examine the triangles. So let me draw the triangle for your understanding. I got A, I got B, I got E, then I got A, I got E, and I got D. This is 2x and this is 2x, this is 90, this is 90, and I've just shown you that alpha is equal to beta. So this is equal to this. Now upon observation, clearly we see that, let me state that upon observation we see that. So what do we see? Angle B is equal to angle D, angle E is equal to angle E, angle A is equal to angle A. So by AAA's criterion or similarity, we can conclude that triangle ABE is congruent to triangle ADE. Now if two triangles are congruent, right, I have stated here CPCTC. So what is CPCTC? Let me state that rule. Corresponding paths of congruent triangles are congruent. So what does it mean? It means this is congruent to this, this is congruent to this, and this is congruent to this. It's a very important statement. So let's go back to the figure. So by that figure, from this understanding, we can clearly state that if I were to take this as A, then this would be A. If I were to take this as H, I can very well state that, as I mentioned to you, they would share the same height. So we can take this as H. So this is the completion of the figure. Now what I would do is I would have to utilize the, let me go on to the next page. Okay, so I would have to find the H here. Now I'm going to consider this H, and I got a A and I got a 25 here. So this is A, B, E. So by Pythagoras law, I hope you can see the diagram. By Pythagoras theorem, what can we state here? H squared positive A squared is equal to 25 squared. I want to extract H, so H squared is equal to 25 squared negative A squared, right? So this is equation 1. So also what I would do is I would like to consider the other half, angle AEC, right? Triangle AEC. So this is what I am considering, AEC. So if you were to consider a triangle, what can you state? You can have H squared positive. This base is A positive 25. So A positive 25 raised to the power of 2 is equal to 40 squared, right? This plus this is equal to hypotenuse. So now that we have got this system, let me rewrite this. This is going to be H squared is equal to 40 squared negative, I'm pushing this, A positive 25 raised to the power of 2. So I take this as 2. So equating 1 and 2, what do we get? In place of H squared, I can substitute what? 25 negative A squared is equal to 40 squared negative of A positive 25 raised to the power of 2. So this is the system. 25 squared negative A squared is equal to 40 squared negative A positive 25 raised to the power of 2. So we need to actually solve this now. So this is equal to, I'm not touching any of these things now. I'm going to rewrite this as negative A squared. 25 times 2, 50 times A, that's going to be 50A, is going to be negative 25 squared, because of the reason it's negative, because of the negative here. The 25 squared is going to be 625. So I already have 25 squared. So what I would do is, let me write that down. 25 squared negative A squared. Negative A squared will get cancelled. I will move this negative 50A to the other side. That will become positive 50A. This is 40 squared, 16, followed by negative 625 and negative 625. So if we were to add this 625 with 625, 5, 5, 10, 1, 5, 6, 6, 6 added with 6 will be 1250. So 1600 and 1250, 0, 0, you get a 10 there, you get a 5, it's already 5 here. From 5 you take away 2, you get 3. So you get 50A is equal to 350. 0, 0 gets cancelled, therefore A is equal to 35 divided by 5. 5 divides 35 7 times. This would mean A is equal to 7. But we know that H squared is equal to 25 squared negative A squared. So 625 negative A squared is 7 squared, which is nothing but 625 negative 49. So let me subtract that. 625 49, carry 1, 15, this will be 6, and 1, carry 1, 11, this would be 7, this is already 5. So you get h squared is equal to 576. Therefore h is equal to root of 576, which is equal to 24. So h is equal to 24 units. Okay, so let me go back to the diagram. So we got h value, we have got a value, we are expected to find the area. So what is the formula for area? So area is equal to half times base into height, base times height. So I need to calculate the base. So base, the entire base, what is the entire base? The total base is what? A is found out to be as 7 units, right? 7 units. So 7 has to be added with 7, and then this has to be added with 25. Let me show you the base here. So one more time, A is equal to 7 units. This is exactly what we will be using. So A is equal to 7, and you got 7 and 7. So 7 has to be added with 7, that's become 14. So my base is equal to 14 added with 25. So 5 added with 4 gives me 9. 2 added with 1 would give me 3. Right? 39 is the base. So let me go back to the problem, or I should say to the working. So base is equal to 39 units. So therefore the total area of the triangle is half times base is 39 and my height. What is my height? My height is found to be as 24. So let me place that. So that is nothing but 24. 2 divides 24 12 times. So I now have 39 multiplied with 12. So what is that? Let me perform the multiplication. 39 and 12. 9 2s are 18. 1 3 2s are 6 7. 9 1s are 9. 3 1s are 3 8. This is 16 and 4. So this is equal to 468 square units. That is the total area for this question. So this is a lovely question, everybody. I hope you all enjoyed, and as I mentioned to you, I'm placing the link on the complete notes on congruent triangles. Please watch that, and thank you so much.